What's going on, guys? Hit pause here with another Unreal Engine 4 tutorial, and in this tutorial what we're going to cover is how to get some AI characters to look at you, basically turn their heads to follow you within a certain range. So if I demo this here, you can see that I got this guy, and if I move over he looks at me, and if I go too far he looks away, and as you can see the other guy starts looking at me as long as I'm within a certain tolerance. You can see they all follow me as I go around, and it doesn't break if they are facing weird rotations. Okay, as you can see there, as soon as I go too far you can see that he looks back straight again. Okay, the angle there is actually 85 degrees that he can turn his head. That way he doesn't break his own neck or turn into what's her face from The Exorcist? I always want to say Gage, but that's the cat from, or not the cat, the little kid from Pet Sematary. Gage. So how do we do this? It's actually slightly confusing. That's why I'm covering it. It's not overly complex, but it can get a little weird, and the reason is that it can get weird is because it gets a little funky when the character can be facing any direction, because look at rotations are kind of like a world space thing. So like right here in the positive Y, say my look at rotation might be 0, and here it might be 180, but if he turns around the look at rotation is still 180, so it's difficult to work with that, and that's kind of what I'm going to show you guys how to handle here. But the very first thing that we needed to do was actually create a I go to the skeleton here, in the character here, the hero TPP thing guy that we got here, this is actually the correct one. On his skeleton you'll notice here that I actually have a head socket that is basically on the bone head. So to add that, just go to your skeleton and just right click and say add socket. You can do this to any bone on your list. So I just came here and said add socket. It named it automatically head socket like that. So I'm using that to figure out where I'm supposed to look, and as opposed to the bone itself. It's just easier to get a reference to that. So when we go here to the blueprints, this is all handled in the anim blueprint here. Okay, it's all done here. You can see that I've got everything almost completely in the animation blueprint here. So the first thing that we need to do is actually create a way to drive the bone itself. And what you can do is, if we go to the default state here, and if that's not showing up, I believe you can pop open the anim graph and you'll get this. So double click the default state, and this, remember, this is just the 3-player template guy. I haven't done anything else to him. When you come here, you get, if there's a video on how they set this up, but if you double click on here, you actually go into this idle run state, and in this part of the state, this right here was hooked directly to the animation pose. This right here is what I've added. So what we've added is a transform modify bone, and if you type bone, it's really easy to find. It's just right there. Okay, transform modify bone, and what you'll notice is that we end up with a component space, and it also outputs to a component space. Now the instant that you hook this up, it actually automatically creates the local to component for you, and it does the same thing here. When you hook this up, it will create the component to local. So just hook them up, it will automatically do that for you. Just wanted to make sure that you guys know that's how I got this. Don't go looking for these or anything like that. Just hook it up and it'll drop it out there for you. So what this transform modify bone does is it basically allows you to control a bone in code. It's pretty simple. And you get a drop down list here, and remember, this is the anim blueprint. It's all tied in, right? You can see all the elements here. We got the animations, we got the mesh, we got the skeleton. So this is tied into the skeleton. So you can just come here and go and basically drop this list down and find your the bone that you want to control here. And what I've done is I want to ignore translation, okay, but rotation mode is set to, from ignore here, I've set it to additive, and I'm using world space, okay, so that it's looking around in world space. It's not component space, okay, or parent bone space or bone space. It is world space, and again we're using BMM additive here. All I did was promote this to a variable and named it head rotation, which ends up coming down right here. And really this is a full transform, so I don't care about the translation, which would be the movement. I don't want to move his head unless I want him to get all attitude-y with me. But then also the scale here is something that we just want to keep at 1, 1, 1. If you wanted him to get like a big head or something like that, you could do that. But I don't, in this case I don't care about doing that. So if I compile this, as soon as we add this and we put it in, you know, we feed it into our blends here, you can see that I can immediately start messing with these variables to turn his head. Okay, I can flip his head around over there. I'm just dragging these up and down. Okay, I can spin his head that way, and I can make him say yes or no. Yes, yes sir. Yeah, yes sir. Yes, Captain. So this Sulu right here, and all he can say is yes, Captain. So this drives that, and now it is blended in a permanent state. Like the way I'm doing it is it's constantly on. This will always work. If this goes down to 0, it'll stop working, and that could be very, very handy if you wanted to say, hey, turn this off if I'm too far away. I don't care about this, right? So you could get a distance to your target and say, okay, well, if it's beyond that distance, then go ahead and set. You can promote this to a variable, and in the event graph you could say, hey, go ahead and set this to off. Somewhere up here in this event graph here, you could say, hey, get a distance to the player character, get a distance to whatever his target is, and then just, you know, drive that value right there. So you can turn this off and on, but in my case here, for simplicity's sake, I'm just going to keep it on permanently like that. So this is all we need right here to actually have control over the bow. But now we need to figure out, basically our worry is this variable right here. So again, that was in the state machine in the idle run blend here. Okay, I just threw it right in there. I think you might be able to put it here as well, probably. But I just put it in here because in this way this will actually work if he's running or standing still. So if he's moving around, he'll still look at me. But if you wanted to have that not be the case, then you could again drive this alpha based on speed. You can say, hey, if you could say if speed is greater than 0, then this is 0, but if it is 0, if he stopped, then he can look at me. Or you could do the opposite. You could say if he stopped, he doesn't look at me, and if he's running around, he is looking at me. Depending on how you wanted to do it, you could tie anything into here. It'd be pretty easy. So back on the event graph, what I'm doing is I am getting the player pawn. Now this character here, remember, pawn owner isn't necessarily me. Now this character is me, essentially. I'm using the same character that I'm controlling, and I'm also using that same exact blueprint as the bot. So we both are sharing this anim blueprint here. Which in that case, I need to make sure that I'm going to check to see if it's me. If this one is my version of it, you know, that the one I'm controlling, then I don't want to do this stuff. So when we get the pawn owner here, which basically gets fed into I have a function here called turn head to player. Now you notice that I named this turn head to player and not turn head to target, because in my case I'm feeding it hard-coded value of me, the player pawn. Now if you wanted him to be able to look at other stuff, like say like a race car driving by or a bird flying, or look at other enemies, or be able to look at other players in a multiplayer game, you'd have to handle this differently. You'd have to figure out how you're going to go about feeding what the target is. The function inside of here can remain the same, but you would want to give him the ability to feed it an actual target, and it'll work with any target. It's just an actor. I think it probably could work with a location too, if you wanted him to look at a point in space, but in that case you would need to be able to feed it a vector. So it'd be pretty simple here. You could just add more inputs for whatever you wanted. The reason that I threw self actor here was just so that I don't have to, inside the function, go ahead and grab try get pawn owner again, because the thing is, you got to remember that this is on tick. So I'm already getting the pawn owner one time through. if I do it again, it's just a waste of bandwidth, right? Basically, it's not that heavy or anything, but it is a waste, so I just want to keep that a little bit, you know, less heavy, so I just feed it what I already got. So once we go in here, this is where it all happens. Now, just to note, the final result is a head rotation rotator, okay, which is basically a vector, but it's a rotation vector, okay. And what I'm doing is I'm interping if I pass all my checks, which basically right now is just seeing, okay, am I within a certain angle of the front of this guy. If it's true, we're going to constantly interpret to that the head rotation to that value. If at any point that fails, we're going to interrupt that back to 0, and we're going to do it a little bit slower. So he kind of, you know, turns his head back a little bit slower. The speeds here are totally tunable. You could make them variables. You could make them default variables in him and read them from here if you wanted to, so that you could have each character. Like if it was a bird or a lizard or something like that, you'd probably want him to, you know, his head to be a little bit more jerky and snappy than a human. So what we do is, we got our inputs here, self actor and the look at target. Okay. The local max head yaw here is basically my tolerance for how far he can turn his head. This is a local variable that I added down here, okay, local max head yaw. And what I don't necessarily like about local variables is that you can't freaking set a default value. You can't on any of them. And I kind of wish you could, because there's no reason why you shouldn't be able to, but I suppose for the most part, local variables are supposed to be taking an input and setting that. But I'm being lazy, and I'm just hard setting it to 85. I never need to change it anywhere else, so I'm setting it here. Again, this could also be a default variable on the character or the player controller, and you could set that there and then read it. You'd have to cast first. You'd have to cast to my character before you could read that variable, but you could do that if you wanted to. For my purposes and our purposes here, I'm just hard coding that sucker. Okay, so I do set self actor here, so that's also a local variable. This look at target, I could have made a local variable for that, but really I'm only feeding it in here and here. So I don't really need to. It's just for the sake of organization, so I don't really care about anything. So the very first thing that we do after we set that local self variable is we check if the target is ourself. Okay? Which in the case of me as the player, it would be, because I would be self, and I would also be the look at target, because if you remember, I am hard coding it the player pawn, which is me. So I want to make sure that it doesn't equal that. Remember, this is a not equal to. Okay, so I don't do anything if it is me. Don't do anything. Okay, so I'm not sitting here trying to look at myself. My head doesn't flip around or stick into my body trying to look at my own crotch or something like that, right? Even though that'd be very interesting. So after that works, we go ahead and we cast as my character. And the reason that we need to do that is because we have to get the head socket. I don't think that you can get that straight from here. Okay, if you type socket, you get nothing. But once you cast, okay, you got all kinds of sockets here. Okay, so we can get, say, get socket location, and that is head socket here. Okay, that's the one that I added here. Okay, which is right there. All right, so I just basically, you can copy and paste this name if you want to, or just retype it. It doesn't really make a difference. So we get the socket and we get its location. Then we get the location to our target, which is here, look at target. So I rerouted that straight to here. We find that look at rotation, okay? And then what we want to do is we want to break it right here. And then here's the kicker. This is where it gets weird. We need to subtract our own rotation from it. Because if we're flipped around 180 and our look at rotation is 180, we need that to be 0. Because we need that to basically say, hey, that's right in front of me. So if we don't do this, what happens is that when I'm behind him, or when I'm actually in front of him, his head will be looking at me, but it'll be flipped around 180, so the back of his head will be following me. Okay? So what we do is we subtract that right here, okay? And we make a rotation out of that. Now remember, I'm ditching the pitch and the roll. I don't care about that. I'm only using the yaw. So I'm subtracting the local self's actor rotations yaw from the lookout rotation yaw, okay? And then I'm making a rotator out of that, all right? That is going to be what I'm going to finally use, all right? That's going to be my final result. Okay, I need to pause for 1 second, although I cannot pause it, but I will be right back in 1 second. I apologize, I have to let this dumb dog in. Okay, sorry about that. Okay, so that is actually what we're going to use for the actual head rotation value. But in order to, what we want to do is now we want to check to see if it's within range. And this is where it gets a little funky, because the range we can check directly versus our rotation to the lookout rotation. Okay, we don't need to actually do this conversion right here to do the check. So we bypass that. Okay, so basically we say, okay, get the active rotation, that's A, we get the lookout rotation, that's B, we break it, we check the yaw, is the absolute value of that, remember, we don't care if it's left or to the left or to the right, we just care that it's within this tolerance, which is, remember, is 85 degrees. If it's less than that, move forward. Okay, if it is less than that, then we interp to our value from here, okay, again with the conversion. And then if not, then we just interp it back to 0, 0, 0, 0 right there. And that's basically it. That's the whole thing. Okay? And that works. So again, we need this. We need a socket. Okay? We need the socket to run our tests from. And we need the controls, the actual node that does the controlling here. We need a variable to drive it. Okay? Again, these things here get automatically generated. This is the one we want to use, transform modify bone. And then we need the function to both A, drive the variable, and B, check to see if it's within tolerance. Okay? Because if we bypass the check, it's actually kind of hilarious. It's kind of creepy, to be honest with you. See, they're all looking at me. But like they're allowed to flip their heads completely around. So they'll look at me, but again, we have to check just to make sure that they don't flip around. Oopsie. So again, the weird part is that we have to take into account the fact that the player can be facing, his rotation in yaw can be 0, it can be 90, it can be 180. It can be 270 or negative 90, right? 270 or negative 90 are the same thing, or 360 or 0 can all be the same thing. So that's why we run this conversion here between our own rotation and that actual lookout rotation. So we get, again, just doing the yaw. Now if you wanted to do the pitch as well, my suggestion would be to run this on a separate chain, okay, down here, that basically comes after these facts, and would drive the pitch separately. Because like say I'm down here, right, and I want him to be able to only look, or I'm up here, I only want him to be able to look so far up, but I still want him to look left and right. I don't want him to like look straight if I'm right here, because he should at least be able to look to the left and right. So personally, I would drive these separately. I wouldn't throw them here with an and. I would do the yaw check, set it, and then I would do a pitch check and set it. Okay, coming out of here, I would run that on a then or something like that. I would do a sequence right here. Okay, first check the yaw, then check the pitch, and go ahead and allow for both of them to be driven separately. That's just my personal opinion. You guys could take that any way you wanted to, because you could say, hey, if I'm up here, he can't see me, so he's just looking straight. All right, and that's it. It works fine, and you can see that each one will look at me regardless of which way they're facing. Okay. So let's do something a little fun here. So I'll do this, and then this, and then So again, this is like, has the ability to test it from basically any angle, right? I got so many in the middle. I'm using the one in the middle to make like a center pivot point. That's all I'm doing there. So I'm just gonna go through and delete those. Okay. So now if I can make it in here, I don't even know if I can make it in here. Yeah, I can make it in here. So as you can see, they're all looking at me. All the ones that can see me are looking at me. God, my camera's all screwy. Yeah, my way, you dicks. See? Pretty much in all cases they work fine. Okay? Every single one that can see me is looking at me. All the ones that are facing too far away, it's really difficult here, are not. So if I go in the middle here, none of the guys that are in the middle are looking at me or trying, because I'm behind them all. But as soon as I get in front of one of them, see, he will look at me. This is one hell of a circle jerk. And as you can see, everyone that I come up behind over here doesn't look at me. Okay? All the other ones do. Now the other thing to note is that right now, like I said, I don't have a distance check, so they're all still looking at me over here. So I would probably run a distance check first to drive that alpha to see if it's even bothering. And then also I'd probably put it in my function as well to say, hey, if I'm out of this range, then, you know, not only set my blend to 0, but don't even process the code, right? There's no point in processing the code if it's not blending in. That's what I would do. And in fact, actually, if you did that, you wouldn't even need to worry about the alpha. You could have any branch check to determine what you're actually going to do. So that's it. They're all looking at me, and again, they're facing any angle now. It doesn't matter. They could also be moving. It wouldn't matter, and it would still work fine. If they turn and they turn too far themselves, this check will run and it will stop them from looking at you anymore. So that's it. And again, the hardest part about the whole thing was basically this right here, figuring this out right here. It took me a little while to get it, but once I did, it works out pretty good. So that's it, and hopefully you guys enjoyed that and found that useful. Hit pause signing off. Thanks for watching, and comment, like, subscribe, and all that fun stuff. And look out for rats next year on Kickstarter. Thank you.